Welcome back. Today's challenge, it's actually in a bit of behind the scenes here. This is the first video I've ever done. And I thought I'd choose a question that I really like because on the one hand, it's not a difficult question. And actually, technically, probably when you're 11, you learn all the skills required to answer this question, but it just reads in a way which makes it sound a lot more complicated. Usual thing, pause the video, have a go, and then I'll move on. Okay, so let's see where we are. So the question wants you to work out the smallest positive integer, so a whole number which consists of only zeros and ones, and which is divisible by 12. Now, so many of these questions are very similar, which is you need to think about the prime factors of 12. And those prime factors are going to be 3, 2, and 2. So if a number is divisible by 12, it must be divisible by 3, by 2, and by 2. Well, that's a bit of a problem. So actually what we're going to need to do is consider a number that's divisible by 3 and by 4, because it needs to be 2 and 2 at the same time. Now, this is one of those things you either know or you don't. So the first thing we need to remember is the divisibility rule by 3 is the digits need to add up to 3. So for example, the number 729, because 7 plus 2 plus 9 is equal to 18. I could do 1 and 8 and carry on going, but 18 is divisible by 3. Therefore, this is also divisible by 3. So the idea, you add the digits up, and I think in another video, we may well look at how to prove that point. The one that some people may not be aware of is the divisibility by 4 rule. Well, that one tells us that for any number, if the final 2 digits are divisible by 4, then so is the whole number. And again, we can look at the proof for that one a little bit later. But as long as we know those two things, then this question is not too bad. If you don't know those two things, this question is near impossible. All right, so let's think about what we need to know. If we start with the second rule, I need this number, which consists only of zeros and ones. I need this number to be divisible by 4, which means I need the last two numbers to be divisible by 4. Well, my choices are only 0, 1, 1, 1, 1, 0, and 0, 0. And that's not divisible by 4, nor is that, nor is that. And although it feels strange, there is no remainder when I divide 0 by 4. So therefore, my final two numbers need to be 0. In other words, my units and my tens. Then I have to ask myself, what do I do with the rest of the numbers? Well, I don't know how many numbers there are, but what I do know is whilst I've done with that one, I need to think about how to create a number using only ones that is divisible by 3. Well, that number can't work, can it? Because the sum of those digits is 1. 1 is not divisible by 3. If I do another one, well, those numbers sum to 2. 2 is not divisible by 3, but I put this number in here, and suddenly I've got a number where the digits add up to be divisible by 3. The final 2 digits are divisible by 4. It's divisible by 3 and by 4, so therefore the whole number is divisible by 12. So my final answer is 11100, or 11,100. That's it for today. As I said, my first ever video, so you may be coming to this quite late on. I'm recording this, so you know, on the 31st of July 2025. Usual thing, like and subscribe please. Let's make this channel grow more. Thank you.